Hello, let me go over the solution for homework number 2. Homework number 2 was covering material for probability. The first problem, I asked you how many different license plates are possible if a state uses 4-letter, 2-digit number, and each number from 0 to 9. So we have 26 letters and 10 numbers. So since we have 4 letters, so you multiple 26 times 26 times 26 times 26 and 2 number times 10 times 10, you get 4, 5, 6, 9, 7, 6, 0, 0. Now, if we change to 2-letter and 4-digit, you're going to have 26 times 26 times 10 times 10 times 10 times 10. You get 676000. That's the correct answer. For the second problem, for breastfeeding and breast cancer, suppose we pick up a woman at random from this sample. What is the probability that this woman will breastfeed? So you're looking at total breastfeed, and which is your event, and that is 1400, 100 times plus 1300, 1400, and you divide by the total sample is 2500, is 0.56, the correct answer. What we call this probability? We call it marginal probability because you're looking at the total for row here. What is the probability woman who did not breastfeed and had breast cancer? So you're looking at the intersection of breast cancer and no breastfeed is 400 divided by total, you get 0.16. What we call it? We call it joint probability. The next one is, what is the probability of woman gets no breast cancer given no breastfeeding? So you're looking at the row for no breastfeeding, which is that row 1100, and how many have breast cancer. So basically, no breast cancer. So 700 didn't have in that row, so you get 0.64. What we call it, again, when you have given, that means it's conditional probability. So the next one asking, what is the probability she has breast cancer or breastfeed or both? So you have two events here. Event 1 is having breast cancer. Event B is breastfeed. So you calculate for those who had breast cancer, which is 500 over 2500, plus those who breastfeed, 1400 over 2500, and then the intersection of breast cancer and breastfeed. If you look at table, that intersection is 100, so over 2500, and you get 0.72. What do we call to calculate this probability? Is additional rule. Now, how many or marginal probability do we have for this problem? So here, if you look at the number of rows and the number of column is just 2 row, 2 column, 4. So that is the number of marginal we have. So problem 3, we are looking to calculate sensitivity and specificity. Again, if you assign A, B, C, D, you get here sensitivity A over A plus C, 980 over 1300 is 0.75. The correct answer for the specificity is D over D plus B, which is 2260 over 2400 is 0.94, and false negative and false positive. False negative is 1 minus sensitivity, which is 0.246, which you rounded to 0.5, and 1 minus specificity, which is 0.05 or 0.06, which is the correct answer. And for positive predicted value and negative predicted value, you're looking at the A over A plus B, 980 over 1120, which is 0.875 or 0.88, and D over C plus D equal to 2260 over 2580, which is 0.88. Again, a similar number you're getting. So that's for question number 3. Question number 4, I gave you those information. It says probability lung cancer or disease is 0.02, probability of a smoker was 10%, which is 0.10, and 1% were a smoker and lung cancer, which is 0.01. So we wanted to calculate the probability D or S, or lung cancer or smoking. You just write the formula: probability D or S equal probability D plus S minus probability D and S, which is 0.02 plus 0.1 minus 0.01 equal 0.11. That's the correct answer. I hope this feedback helped you to understand better the material.